So in our first example, Chugs the Stick Figure Man has found his way out to the forest and is planning on chopping down a nice short tree to fit inside of his house for Christmas. Please note that the tree is in fact to scale and that Chugs the Stick Figure Man lives in a one-bedroom apartment. He's been known to make questionable decisions. Now he wants to make sure that this tree is going to fit inside of his one-bedroom apartment, so he takes an instrument that measures angles of elevation and places it out here so that he can determine what the height of the tree is without actually having to climb it himself. It is discovered that the angle of elevation that is created is 52 degrees when the distance between him and the tree happens to be, let's see, if he's about 6 feet tall, we'll call that 6, 3, 4, 5, 6, we'll call that 40 feet. I did mention that he makes some questionable decisions, correct? So we'll pose the question, how tall is this tree? Now hopefully everybody realizes that what I've done here is essentially draw in a right triangle. The height of the tree would be acting as one of the legs of the right triangle, and because it's an unknown, we're going to refer to it as a variable. So we'll define h to be the height of the tree. Now from the perspective of the angle that we know, 52-degree angle, we have a hypotenuse, we have an opposite side, and we have an adjacent side. The known side of 40 feet, from the perspective of the 52-degree angle, would be the adjacent leg. The unknown side, which is our height, from the perspective of the 52-degree angle, that would be the opposite side. So we get to pose the question of our big three trig functions, sine, cosine, and tangent, what will relate the opposite and the adjacent? Now the opposite and the adjacent appear together in this part. That would be the tangent is equal to the opposite over the adjacent. So what we're saying is the tangent of our angle is equal to the opposite side over the adjacent side. Next, let's plug in what we do know. The given angle was 52 degrees. The adjacent side was 40 degrees. And the unknown side, that is our h, would go up top. Now, this is what the initial setup would look like. We haven't actually finished solving for h. So what I'm going to do is to solve for h, multiply both sides by 40. 40s will cancel on the right-hand side. You'll have h is equal to 40 times the tangent of 52 degrees. Now, here's where you can pull out the old graphing calculator, or scientific calculator would work as well. And let's get a decimal approximation for this quantity. So first, going to double check, make sure that the calculator is in degree mode, which it is. We want 40 times the tangent of 52 degrees. 40 times the tangent of 52 degrees, if we round that off to the first decimal place, we can call that about 51.2 feet. So what do you think? Should Chugs the Stick Figure Man take this 51.2 foot tall tree and put it in his one-bedroom apartment? I say go for it. Just don't expect a security deposit back by all means. My goodness. Now, let's consider another example. So I've been meeting with students from my home recently, and I just wanted to draw everybody a quick picture of what my home looks like. It looks basically identical to this, and there's no way that you can convince me otherwise. I have a nice window right here, and inside that window, everybody knows what I am sketching right here. That is my incredibly beautiful cat, Wednesday. Wednesday, Thursday, Friday, or WTF for short. It's where she likes to hang out, just staring out the window all day. Now, unfortunately for me, I have some beautiful trees around my house as well, and the trees spread leaves onto my roof, and the leaves get stuck in the gutter, and therefore I need to make sure that my gutters stay clean. The way that we make sure that our gutters stay clean is we grab a ladder. We put the ladder on the side of the building, and we angle it kind of like this. And the angle is the important part to make sure that we don't fall off the ladder. Now, according to safety standards, I need an angle of approximately 70 degrees right here. I measured my angles, my gutters are 12 feet off the ground. My question is, how long should the ladder be to make it to the gutters? Now, you may have noticed that as I was drawing this beautiful picture of my home, that I drew in a vertical side of 12 feet, and we are wondering how long should the ladder be. I'm going to use L for length of the ladder. Oh, L works twice. That's great. L for length of ladder. So how long should the ladder be in order to make sure that it gets to the gutters? Well, from the perspective of the 70-degree angle, the known side would be 12 feet, and that is going to be equal to, from the perspective of the 70-degree angle, that is across, so that would be the opposite side. Then the unknown side would be the length of the ladder. From the perspective of the 70-degree angle, that is the slanty side, that would be the hypotenuse. Then, of our big three trig functions, which one is going to relate all of these together? Well, we have the opposite and the hypotenuse, so we have a winner, winner, chicken dinner for the sine. So the sine of the given angle is going to be the opposite over hypotenuse. When we plug in the things that we do and do not know, the angle that was given to us was 70 degrees. The opposite side is 12 feet. And the hypotenuse is the length of the ladder. Now, similar to what we saw for the previous problem, we can begin solving this by multiplying both sides by L. We get L times the sine of 70 degrees is equal to 12. To finish solving for L, I want to get that sine of 70 degrees over to the other side, so this will be 12 divided by the sine of 70 degrees. Here's where we can let the calculator take over since we have taken care of all of the algebra. So from the calculator, we've already verified that we're in degree mode. This will be 12 divided by the sine of 70 degrees. It looks like the ladder needs to be at least 12.77 feet long. Now, if the ladder happens to be longer, I can rest the edge of it above the top, and that would probably be what's responsible. Yeah, do try to make smart decisions if you're going to be crawling on the top of a house, especially if it's the top of my house. I might call the cops if I don't know why you're trying to climb on top of my house. But yeah, I will be sure to give Wednesday some extra pets for everybody. So, thanks, PB.